What if Earth fell into the sun? The complete scientific reality. Imagine standing outside on a normal day. The sun is 150 million kilometers away. Earth orbits at precisely 30 kilometers per second. This balance has existed for 4.5 billion years.
But what if something went catastrophically wrong? What if a rogue planet passed through our solar system, or a near miss with a black hole disrupted our orbit? What if Earth's velocity dropped and we began falling toward the sun? This isn't fantasy, it's physics. And the reality is far more terrifying and scientifically fascinating than any disaster movie. Over 65 days, Earth would experience a transformation so complete, so violent, that by the end, our planet wouldn't just be destroyed, it would cease to exist entirely.
Let me take you through exactly what would happen, day by day, based on real orbital mechanics, thermodynamics, and astrophysics. The disruption. Something has changed Earth's orbit. Maybe a massive gravitational anomaly. Maybe a direct collision course was set by an astronomical event. Whatever the cause, Earth's orbital velocity drops from 30 km/s to 28 km/s. Within hours, astronomers detect the anomaly. Calculations begin immediately. Supercomputers run simulations. And the answer comes back the same every time. Earth is falling toward the sun. The trajectory is set. 65 days until we reach the solar surface.
The realization. For the 8 billion people on Earth, panic would be inevitable. But let's focus on the planet itself. Solar radiation increases by 2%. You wouldn't notice yet. The sun looks the same size. Temperatures rise half a degree globally. But we're already traveling inward at increasing speed. Day 5 to 7, measurable changes. By the end of the first week, Earth has traveled 12 million kilometers toward the sun. We're now 138 million kilometers away, still far beyond Venus's orbit at 108 million kilometers.
Solar radiation has increased 5%. Global temperatures rise 3 degrees Celsius. This is measurable. Weather patterns shift. The sun appears 8% larger in the sky. Earth's velocity increases as we fall deeper into the sun's gravity well. We're now traveling 35 kilometers per second, faster than our normal orbital speed. By day 15, we've covered 40 million kilometers. We're 110 million kilometers from the sun, past Venus's orbit. Solar radiation has doubled. Global average temperature, 35 degrees Celsius. That's 95 Fahrenheit everywhere on Earth. Average day and night, poles to equator. The effects are no longer subtle.
The oceans begin to evaporate. Earth's oceans contain 1.4 billion cubic kilometers of water. Under normal conditions, evaporation and precipitation balance. Not anymore. With doubled solar radiation, evaporation accelerates dramatically. Ocean surfaces release steam continuously. Humidity skyrockets. The atmosphere becomes saturated with water vapor. This is called a runaway greenhouse effect. Venus experienced this billions of years ago. For Earth, it happens in weeks.
The atmosphere transforms. Atmospheric water vapor has increased 300%. Clouds cover the entire planet. Thick, white, impenetrable. From space, Earth no longer looks blue. It's a white sphere wrapped in superheated steam. Surface temperature, 55 degrees Celsius, 131 degrees. Atmospheric pressure increases by 15% due to the added water vapor. Breathing becomes difficult in many regions. Plant life begins dying en masse. Forests ignite from the heat. The Amazon, the Congo, Siberian forests, all burning simultaneously. But remember, we're focusing on the planet, not the tragedy of life. The biosphere is collapsing, but Earth itself continues its journey.
Beyond Venus, Earth has traveled 80 million kilometers inward. We're now 70 million kilometers from the sun, far closer than Venus at 108 million. The water hasn't disappeared. It's in the atmosphere. Atmospheric pressure has increased to 1.4 bar, 40% higher than normal. The air is so thick with steam that visibility drops to meters. From space, Earth is completely white. No land is visible, no blue oceans, just an opaque sphere of cloud, and we're only halfway through the first month.
Inside Mercury's orbit, the hellish transformation. Earth crosses Mercury's orbit. Mercury orbits at 58 million kilometers. We're passing through that zone now. Solar radiation, 7 times Earth normal intensity. Surface temperature, 200 degrees Celsius, 392 degrees. This is the boiling point of water at normal atmospheric pressure, but pressure is no longer normal. At 1.5 bar, water's boiling point is higher. Still, evaporation is total. The oceans are gone, not dried up, vaporized completely. Every drop of water that once filled the Pacific, Atlantic, Indian, Arctic, and Southern Oceans is now in the atmosphere. Atmospheric escape begins, but the atmosphere itself is in danger. At 200 degrees Celsius, hydrogen molecules move at 2.4 kilometers per second. Earth's escape velocity is 11.2 kilometers s. Hydrogen isn't fast enough to escape yet, but the sun's influence extends beyond heat. Solar wind, a stream of charged particles flowing from the sun at 400 kilometers s, begins stripping Earth's outer atmosphere. Earth's magnetic field, generated by our molten iron core, normally protects us. The magnetosphere deflects solar wind, creating a protective bubble. But at this distance, solar wind intensity is 50 times stronger than at Earth's normal orbit. The magnetosphere compresses. On the sunward side, it's pushed to within 6,000 kilometers of the surface, half its normal distance. On the night side, it stretches into a magnetotail millions of kilometers long. Atmospheric particles ionize and stream away along magnetic field lines. Earth is bleeding its atmosphere into space.
Some soften. Granite, which melts at 1,200 underground sea, visible even on the day side, brilliant on the night side. The night side still exists. Earth continues rotating, though tidal forces from the sun are beginning to slow it. Rotation period has increased from 24 hours to 26 hours. Crustal fracturing. Distance 30 million kilometers. Temperature 700 degrees Celsius, 1292 degrees. Thermal expansion is destroying the crust. As rock heats, it expands. Different minerals expand at different rates. This creates internal stress. Microfractures form. They grow. They connect. Massive cracks appear across continents. Not tectonic activity, thermal stress fractures. These cracks are hundreds of kilometers long, kilometers deep. Volcanic activity erupts globally, not from plate tectonics or mantle plumes, but from crustal failure. Magma under pressure finds new pathways to the surface. The Earth's crust, once stable, is fragmenting. From space, Earth is orange-red, glowing, fractured, with no atmosphere visible, approaching the Roche limit. What is the Roche limit? The Roche limit is the distance at which tidal forces from a massive body exceed the self-gravity holding a smaller body together. For Earth orbiting the Sun, the Roche limit is approximately 2.5 solar radii, or about 1.7 million kilometers from the Sun's center. Outside this limit, Earth's gravity keeps it intact. Inside this limit, the Sun's tidal forces tear it apart. We're approaching that boundary.
Tidal forces intensify distance, 20 million kilometers. Temperature, 1,000 degrees Celsius, 1,132 degrees Celsius. At this temperature, aluminum melts. Most rock is softening. The surface is no longer solid in the traditional sense. It's a viscous, glowing shell. But temperature is no longer the main threat. Tidal forces are. The sun's gravity pulls on Earth's near side stronger than its far side. This differential force, tidal force, is proportional to 1 VEO3, where r is distance. At 20 million kilometers, tidal force is 140 times stronger than at Earth's normal orbit. Earth begins to deform. Entering the Roche zone. Distance, 10 million kilometers. We're inside 6 solar radii now. The Roche limit is at 2.5 solar radii, 1.7 million kilometer. Tidal forces increase exponentially as we fall. Earth's shape distorts further. The elongation is now 200 kilometers. The near side bulges toward the sun. The far side bulges away. Internal stress builds. The mantle, already semi-molten, flows under the deformation. The crust fractures catastrophically. Chunks of crust, sections the size of countries, break free. They don't fly off into space. They're held by Earth's gravity, but barely. They shift, slide, collide with other sections.
Structural failure, distance 5 million kilometers. Temperature 1500 degrees Celsius, 2632 degrees. Earth is no longer spherical. It's elongated, distorted, fractured. Tidal forces now exceed Earth's structural integrity. The mantle tears. The crust disintegrates into massive fragments. Material streams toward the sun. Earth's iron core, solid in the center, molten in the outer layer, resists longer than the rocky mantle. Iron is denser, stronger. The core holds its shape even as everything around it falls apart, but it won't hold forever. The planet dies distance, 3 million kilometers. This is where Earth ceases to be a planet. Tidal forces pull the mantle completely apart. Rocky material, molten, vaporized plasma, streams away in both directions, toward the sun and away from it. The iron core, now exposed, continues inward. Behind it, a trail of debris, rock fragments ranging from mountain-sized to grain-sized, all glowing white-hot. From a distance it looks like a comet, a massive glowing tail stretching millions of kilometers. But it's not a comet, it's the remains of Earth. Approaching the corona distance, 1.5 million kilometers, the iron core is still somewhat intact, a sphere of molten metal 3,480 kilometers in diameter, compressed and superheated. Surrounding it is a debris field, vaporized rock, ionized metals, plasma clouds. Temperature, 5,000 degrees Celsius, 9,032 degrees.
Vaporization complete. Everything, rock, metal, core, vaporizes instantly at coronal temperatures. Atoms ionize. Iron atoms lose electrons, becoming Fe2+, Fe3+, up to Fe14+. Silicon, oxygen, magnesium, all reduced to their most basic components. The debris isn't a solid or liquid anymore. The final moment. The last remnants reach the chromosphere, the layer just above the photosphere, where temperature is around 4,000 degrees Celsius. For a brief moment, instruments might detect a slight increase in iron content in that region of the sun. A small brightening might appear on the photosphere, so subtle that only specialized solar telescopes would notice, and then it's over. Earth, 6x 1024 kilograms of rock, metal, water, and everything that ever existed on it, has been absorbed into the sun. The sun's perspective. The sun's mass is 2x 1030 kilograms. Earth's mass is 6x 1024 kilograms. Earth represents 0.0003% of the sun's mass. If the sun were a person weighing 70 kilograms, Earth would be 0.21 grams, less than a quarter of a gram. A single small pill, the sun wouldn't notice.
Solar effects. Would there be any measurable change? Temperature? No. The sun's core temperature is 15 million degrees Celsius, maintained by nuclear fusion. Adding Earth's mass doesn't change this. Luminosity? No. The sun's energy output, 3.80 1026 watts, is determined by the fusion rate in the core. Surface disruptions don't affect this. Surface features, minimal. The region where Earth's material merged might show a temporary brightening lasting a few hours or days. Solar convection would mix the material throughout the photosphere within weeks. Chemical composition, slightly detectable. Earth contains more heavy elements, iron, silicon, than the sun's surface. What about life? I've focused on planetary physics, but let's briefly address life. When does life end? Day 7, ecosystems collapse. Temperatures exceed survival limits for most species. Mass extinction begins. Day 15, surface temperatures, 35 degrees Celsius average, much higher in equatorial regions. Day 30, no liquid water remains. Life, as we understand it, cannot exist. Every living thing, every human, animal, plant, microbe dies within the first month, long before Earth itself is destroyed.
Rogue planet. A planet-sized object passing through the solar system could gravitationally perturb Earth's orbit. Probability: extremely low, but not zero. Black hole. A stellar mass black hole passing through the solar system would wreak havoc, but we'd detect it long before it arrived due to gravitational lensing effects. Three-body problem instability. Over billions of years, gravitational interactions between planets could theoretically destabilize orbits. Simulations suggest the solar system is stable for at least another 5 billion years. The reality: Earth's orbit is stable, remarkably stable. It's been essentially unchanged for 4.5 billion years and will remain so until the Sun becomes a red giant in 5 billion years. This scenario is hypothetical, but the physics is real.
Conclusion: what this teaches us. This thought experiment reveals profound truths. Orbital mechanics are precise. A 7% change in velocity would put Earth on a collision course. We orbit at exactly the right speed, at exactly the right distance. 2. Stellar objects are incomprehensibly powerful. The Sun, which sustains all life on Earth, would barely notice our planet's destruction. 3. Planetary survival depends on balance. Earth exists in a narrow, habitable zone, not too hot, not too cold. Move us 5 million kilometers inward, and we become Venus. Move us 5 million outward, and we freeze. Physics is indifferent. The universe operates on mathematical principles. Gravity, thermodynamics, fluid dynamics. They don't care about life, history, or meaning. They simply are. 5. We are fragile. Earth seems vast and eternal. But against cosmic forces, stellar gravity, tidal disruption, solar radiation, we're a delicate speck. And yet, we exist. We orbit at 150 million kilometers at 30 km/s. The Moon stabilizes our rotation. The Sun provides energy. The magnetosphere protects us. This balance has held for billions of years. It will hold for billions more. This is what would actually happen if Earth fell into the Sun. This is the reality of planetary physics. This is our universe.